Hey guys, so you just finished watching the video of hydrochloric acid and sodium hydroxide mixing together and turning from a very acidic solution and a very basic solution into a neutral solution. Now we're going to get into the chemistry behind that and why that happens. So yesterday you looked at a bunch of examples of neutralizations, and here's the chemistry behind it. So when we're talking about neutralizations right now, we are talking about strong acids and strong bases. So with strong acids, we know that they are going to completely dissociate and they are going to donate H pluses or those hydrogen ions into solution. And then your bases are going to completely dissociate and they are going to donate the OH minuses or the hydroxide ions into solution. So if we look at our HCl here, remember this is going to split up into H plus and Cl minus. And then our sodium hydroxide is going to split up into Na plus and OH minus. This is what makes HCl acidic. This is what makes NaOH basic. When we have a neutralization reaction, what's really happening is the acidic part of the HCl is matching with the basic part of the NaOH, and they're neutralizing each other or balancing each other out. The way we can represent that is by showing them bonding together as an HOH, which also can be written as an H2O, right? So creating water, which we know is a neutral substance. It has a pH of 7. So we know that one of our products of this reaction is going to be water. The other product we can see up here is going to be NaCl, which is table salt, which is also a neutral chemical. It also has a pH of 7. So if we take a step back here, what's really happening in this reaction is it's a double replacement reaction. So we've done double replacement reactions a whole bunch of times. We're going to switch our cations. So H will go with OH, Na will go with Cl. The reason we call this a neutralization reaction is because we're taking something that's acidic, we're matching it up with something that's basic, and we're creating two neutral products as a reaction. So once we write it all out, you've got your H2O and your NaCl. So what we need to know about neutralization reactions, in addition to why they're called neutralization reactions, the process of neutralizing or becoming neither an acid nor a base at a pH of 7. The other thing that we need to know about these is that they are always going to be an acid plus a base create water plus a salt. So this is salt, this is table salt, this is what we refer to as salt. We're not always going to create NaCl, but we are always going to create what we call a salt or a neutral compound, like an NaCl, but not necessarily made up of the same cations and anions. So depending on what your starting acid and bases are, you're going to see different chemicals here, but what's important to note is that they're always going to be neutral. They're always going to have a pH of 7 if we're dealing with a strong acid, strong base neutralization like the ones that you're going to see.